Hi, good evening, good afternoon, good morning, wherever you are. My name is Salil Amankar. I'm the Global Head AI for Manufacturing and Retail for Pluto 7. And the theme of the presentation today is AI and machine learning in real life. I'm going to go through various examples in multiple industries of where we have seen AI and machine learning make a difference in terms of actual business results. I would like to request everybody to think about their questions as I go through this presentation, and towards the end I'll leave about 5 to 10 minutes or more, depending on the questions, and answer them. So with that, here we go. So a little bit brief about me, followed by a brief about our company. As I said, I'm the Global Head for Manufacturing and Retail. My expertise is as a thought leader and a domain expert primarily in supply chain and most enterprise processes. I'm considered as an industry expert in the manufacturing and the retail industry. I have a business management consulting experience of 12 plus years, where I've worked with various companies, the likes of Cisco, which was my alma mater at one time, General Motors, General Electric, some retail companies, as well as high-tech companies in addition to Cisco, and so on. A few points about myself. I've been working with AI and machine learning over the past 4 years on Google Cloud Platform, and I'm a certified Google professional. A little bit more about our company, and then I'll get to the meat of the context that I want to share with everybody today. We are Pluto 7. We are a premier Google partner, and we are focused in providing AI, machine learning, and based solutions to the retail, manufacturing, high-tech, and the healthcare industry. Our concept is basically to take the end-to-end enterprise process, which starts with marketing and then sales, to the actual fulfillment to supply chain, and we have machine learning solutions that span this entire spectrum, as you'll see. We are located in primarily in the U.S. West Coast. We are planning to expand in the rest of U.S. We service North America mostly, and we also have an office in India right now in Bangalore, where we supply where we service most of India as a Google partner, and will expand into Asia. So let's look at some of the real-world examples as with the theme that I shared in terms of the enterprise processes. The way we have seen our solutions help customers is, at the end of the day, we help our customers target and acquire the customer demand generation. This has to do with demand generation, how to do that most effectively, leveraging AI and machine learning. Follow that up with how do you make sure that you maximize and your customer adoption, as well as provide more value and you retain the customer. And then obviously, in order to keep the customer happy, you need to make sure that you are servicing the customer flawlessly with their expectations. So the theme being, we have solutions, what we call as marketing machine ML, the sales ML, and supply ML that pretty much are the underpinnings of the solutions that we provide our customers. So some of the problems that we have seen that we have either solved or are being solved in using machine learning and AI, when you talk about demand generation, demand forecasting, there's a lot of opportunity here to really get higher demand accuracy in terms of your forecast accuracy, leveraging AI and machine learning. How do you then follow that up with understanding the supply constraints, mapping that with your supply-demand balancing to avoid shortages and also oversupply? When it comes to actually providing a superior customer engagement, how do you determine who your top customers are? What is it that your customers care about? What are their sentiments? And then how do you service your customer at scale in a way that they feel that they have an awesome customer experience? And other opportunities, as you'll see as I go down through the presentation. So consistent with what I have shared, and from a Pluto 7 perspective, we have solutions that fall into these three key areas. Around marketing, it has all to do with, as I said, how do you really effectively generate your demand and acquire your customer. That has to do with how you effectively target your customers with the next best action. How do you effectively do your campaigns? How do you improve, for example, if you are a brick and mortar retailer, predict the customers coming into your stores and then drive it to do operational efficiency. On the sales front, how do you identify which customers are your premium customers, which customers are at risk, so you can at least make sure you retain them. On the supply chain side, you have demand forecasting, supply planning, and also if you're a manufacturing-centric company, how do you do predictive preventive maintenance to have better quality control, avoid downtimes? More importantly, how do you drive productivity within the manufacturing floor? Moving on, here are some examples of solutions that we have provided our customers. For example, for the world's largest brewery, which is AB InBev, we have helped them improve the taste of beer by having an AI machine learning based solution that identifies at what point of time is the beer filter has to be replaced in the most optimum fashion, and also improve the beer throughput. For example, for a really disruptive retailer, we can help reduce the inventory carrying cost across the supply chain by having a really efficient forecast that can be then used to drive their entire supply chain, as an example. Or in case of a high-tech company, how do you forecast the hard-to-forecast products and then reduce the bullwhip impact in the supply chain, as an example. Or if you are interested in some really creative pricing, or if you want to really maximize revenue by doing pricing, how do you do that in almost real time that correlates with your demand and sentiments of your customer, as an example. So let's start with retail as one of the industries that I will talk about today, and let's look at a solution that we implemented for a retail customer. So in this case, when you talk about retail, today's retail is, you'll hear the word omni-channel a lot. The end customer today wants to have the ultimate flexibility. As a retailer, you need to be able to be very smart about how do you identify what your customer sentiments are, how do you plan for your entire supply chain, how do you plan for what products you want to offer, all the way from marketing those products, and then combining that with the efficiencies of marketing all the way down to supply chain. So here's an example of one customer where they're what I call as a disruptive retailer. They sell bed sheets through multiple channels, which is they sell as fulfilled by Amazon. They sell as their own e-commerce site. They are also selling through brick and mortar retailers as well. They have distribution centers in U.S. and they they actually source their products from factories in Asia. So what are the typical challenges when you talk about such an operation is, how do you make sure that you tie your demand generation in multiple channels in an effective manner with changing fashion, with changing sentiments? How do you do demand forecasting that's believable, and then can you use that to drive your supply chain inventory levels at each node in the supply chain, whether it's your distribution center or in your factories, so that you don't end up in having too much inventory carrying costs by trying to carry a safety stock, which is a typical answer to this problem. And so this were the challenges that the customer came to us and said, well, can AI and machine learning help? And so we did help them. And the way we did is, from the e-commerce side, we looked at, for example, what's the traffic of the customer and what is their as the details of how they traverse the e-commerce site. Plus, we added that onto that. What's the historical demand look like? All these multiple factors is what we used to feed in as features, as typically people who are familiar with machine learning, but for the layman, think about it as inputs that we fed into a machine learning model that we developed, which was a customized machine learning model using TensorFlow on a Google Cloud platform that learned from all these variations to then come up with a highly accurate forecast. That was the end result. But just having that forecast then be used to drive the supply chain was the crux of solving the problem for this retailer and having them have a scalable operation. And so the end result was, I'll come back to the architecture in a moment, the end result was 50% reduction in inventory carrying costs, which is significant, improved obviously forecast accuracy at a SKU level, and better insights into how each of their SKUs performed. So all of this was very significant in terms of the benefits, and some of these are some things that are only possible when you have like a machine learning model solution that can work in concert with the rapid changes in demand, the sentiments, etc. So just for those who are architecturally oriented, here is a view of the architecture that we use based on Google Cloud Platform. Since this was a weekly forecasting capability, we had a batch load that was automated, which loaded all the information around sales, the product view, the page view data onto the Google Cloud source. We then took it, cleaned it, processed it, fed it into the machine learning model that operated and then presented the information as to what the forecast is in a manner that the customer wanted. So moving on to the next industry, now I'm going to talk about supply chain, manufacturing and supply chain. And on this one, this particular solution and a project that we did for a customer, which was the world's largest brewery, it won the 2019 Gartner Supply Chain Award for Innovation for CPG. What we did here was, as I had already, I think, alluded earlier, we put in a solution that helped identify what was the optimum time to replace the beer filter. The problem is if you replace it too early, you are leaving good production capability that is unused, or if you replace it too late, you produce beer that has to be thrown away because it doesn't meet the quality standard. Typically, this is done by human decision-making through a brewmaster. Again, what we did was we took a lot of the inputs and we used the Google Cloud Platform. The architecture is similar to something that I had shared earlier, so I'm going to skip through this. We took all the inputs, we fed it into the machine learning model. The idea is to optimize on two important characteristics that control the beer quality, which is what they call as output turbidity, and at the same time, the filter differential pressure should not exceed certain thresholds for safety. So we optimize for that, and the net result is, you can see here the before and after. We got a 44% improvement in terms of how the beer production improved before and after in case of one line, and in case of the other line, it actually improved even more to the tune of 80%. So as a result of these significant business impacting results, the decision was made by this customer to then roll out this solution to other brewery lines as an example. Moving on to another industry and continuing the theme of real value being shown by using artificial intelligence and machine learning, we move on to healthcare, and I want to share with you an example in healthcare where we leverage AI machine learning to improve productivity. In this case, it has to do with improving the productivity of making decisions on clinical trial processing. So typically this is done by, again, human beings, where somebody has to read through a whole boatload of information from multiple things, the results coming out of clinical trial, which they call as protocol, the results, then the protocol, meaning what is the protocol of expected treatment that had to be done as a part of the clinical trial, then the results that they're expecting at each stage, put it all together and then come up with a decision, and the decision point is whether this clinical trial is eligible for Medicare or is it eligible for research, or if it is not eligible for either one of them. Again, what we did here was we using machine learning, and in this case, we looked at taking a text, taking NLP out of the text to come up with what is the sentiment, not only the sentiment, what are the core elements that are important from a decision-making perspective, compare it to a dictionary of expected phraseology, and then populated a decision matrix that allowed the AI model to then render a decision that said, okay, this clinical trial met either the Medicare criteria, or it met the research criteria, or it didn't meet either of this criteria. The end result was a more than 80% improvement in productivity, as an example. So again, how it works, basically take the clinical trial results, you put it on Google Cloud Platform, you use NLP, which is the text processing that I discussed, then you have a machine learning model that takes that output and makes the decision, and then that's pretty much the output. So moving on, and if I encourage people to put their questions, which I'll answer, as I said, towards the end of the presentation. So here are the results. I mentioned already 86% in accuracy, and as a success of this, there is a follow-on work that we are doing with this institution. So we talked about retail, we talked about manufacturing, supply chain, we talked about healthcare, and finally I want to talk about the high-tech industry and how we see AI and machine learning give real results in this industry, and take you through a case, one of the cases where we were able to, again, see awesome results. So in this case, we talk about a company which is they are actually having multiple lines of business, one of which is a subscription-based, e-commerce-based business. And the key thing here was to figure out a way to improve the identification of risky customers ahead of getting the subscriptions renewed, whether it was a SaaS subscription or whether it was a long-term contract. So again, based on past history and using the past data about how the service contracts were renewed, as well as looking at other information, including some of the third-party information, and that led us to also get an idea about the consumer sentiments. We came up with a model that would then take all this information, we have the model learn from the past, and the end result is identify which of the customers are at a higher risk to churn, so that the company's sales folks could spend their energies in working on retaining these customers, while the other customers who would sign the renewal contracts on an expected basis, you could almost put them on a virtual renewal. So the net here is you have productivity in your sales force that's handling renewal, but more importantly, you're able to keep customers who you would have lost otherwise by taking efforts to work with them and identify what is required to be done to keep them. So at the end of the project, the results were we had about a 92% prediction accuracy in correctly identifying the high-risk customer, which was good enough for the enterprise to say, okay, we're going to funnel this set of renewals into a separate focused sales efforts, and then while the remaining ones could be handled by a regular or a virtual team, which like I mentioned earlier, enabled the enterprise to have higher customer retention and then also productivity in how they went about their sales of the renewal process. So I talked about 4 industries, and I gave you examples after examples of how machine learning and AI has helped deliver real results. I want to also give the perspective being from the supply chain. I come from a deep experience in supply chain, that there's this whole opportunity now, and I see enterprise after enterprise trying to work on this. When you're talking about supply chain, it's really multiple enterprises coming together. The use cases I talked about initially have to do with improvements within an enterprise. But with AI and machine learning and all these other technologies, which I'm going to rephrase in the subsequent slide, we have a huge opportunity to really improve what I call as the feedback loop between each connections within the supply chain. Typically, this is what happens for those of you who are familiar. You have your plan and you go with your plan, but as expected, there are obviously changes to the plan that happen. And then when these changes happen, it's not just going to impact one enterprise, it impacts multiple enterprises. So how do we leverage AI and machine learning to have a better connected supply chain is the opportunity I want to talk about at a very high level. I'm not going to go into levels of details around this. But the opportunity becomes more and more real, and there are enterprises working on this in a very phased roadmap manner. And the way to give you that perspective is to look at it from each element of the supply chain. You start in a typical supply chain, you have the strategic planning function that follows, that is then followed by a sourcing, and then you have from a planning, the strategic planning, the sourcing, setting up the supply chain, your distribution network, but then you also have the execution happening, which means your order fulfillment, your demand management, your controlling of that inventory, the distribution, and at the end of the day, it's how do I make sure that this entire process end-to-end is operating in the most efficient manner, the performance and the metrics that go with it. So in this, you'll see multitude of enterprises being involved. You could be a supplier to an OEM, and you could be a distributor as an example. So the point here is you have opportunities at each node, like for example, from planning to sourcing to manufacturing to managing the order fulfillment to the distribution at each node to really make this effective not only at the enterprise level, but intra-enterprise level as well. And that's where the power of AI and machine learning also exists. And to show you an example of this, again, this is something where one of our customers is already on the path. Having seen the success of AI and machine learning, now you can see there are some real use cases that they are looking at across the entire supply chain to solve using machine learning and AI. So just wanted to give everybody a perspective of not only is AI and machine learning going to be helping delivering real business results within an enterprise, but it also has the opportunity to deliver results across the supply chain. So what are some of the key technologies that are enablers of this? Well, a few of them, or most of them, are what I would like to talk about in brief here. At the bottom, you have the core technology elements, which is the Internet of Things, IoT, the big data management, because huge data is produced when you talk about Internet devices or data collection, cloud computing, which is whether public or private cloud, machine learning as a disruptive technology, and then things around all the emerging devices, and then some of the specialized devices like augmented reality, virtual reality that really is helpful in the whole human AI or automation interaction. Some of these aspects that typically impact the supply chain is the human-machine interaction, because it's at the end of the day, there has to be, it's about making the humans more effective and removing the mundane tasks and letting the humans only interact when there is an exception. How do you make sure that all the various systems that exist in the supply chain within the enterprise are connected? There's all this system integration and advancement, which is enabled, by the way, by the cloud computing. There's all this simulation analytics on all this advanced analytics capabilities that are now becoming more and more real. And then the most important, the real-time data analytics, which means when you're talking about making decisions on the shop floor when the lines are operating at seconds, such as if you talk about beer production, they have like 33 beers or cans being produced per second, then you have to have that level of speed in processing the data that I showcased earlier. So these are some of the key technologies that are the enablers of some of the concepts that I talked about earlier. This is just for those who are architecturally oriented. All this is showcasing is if we are looking at Google Cloud as an example, how would that typical architecture look like? The key components I want to talk about here are, at the end of the day, is the edge. I talked about the speed in my earlier slide of the speed, for example, that's needed in certain operations, the business real-time connectivity, the edge machine learning capability, and having a TensorFlow-like model is critical there. The ability to connect between, for example, the cloud to the edge, where you need to have the speed that becomes critical. And then you have the various specialized components from a storage to the processing. You need to have very scalable data pipelines that will process the data at speed. That you need to obviously have the machine learning capability to not only train, evaluate, but also to have the prediction being done at scale, whether it is running off the cloud or at the edge, as an example. So you have heard me talk about all the practical applications of machine learning and AI. I want to share with you some of the best practices, having worked on providing solutions to our customers. What are the 5 key practical steps? The first thing is to make sure that you are selecting the right use case that machine learning can actually support. The second then is making sure machine learning can only work with when data is there, because it is learning that has to be derived from either past experience or what's actually changing in data. So if you don't have data, the machine cannot learn. Similar to like as a human being, if you don't have instructions from your time from when you're a baby to you're actually a mature adult, you are learning from different interactions, whether it's from your parents, from your teachers, from your experiences. The same way that data becomes important. Another aspect is to make sure that enterprises see machine learning as an innovation and that it is real and not as a sci-fi. But it means, when you talk about innovation, it means experimenting. And it means taking experiments, proving the results, and then taking them to production. Making sure that you're not looking at it as a technology, but you do that in concert with the business know-how. So again, you maximize the right business problem to be solved by leveraging the right model or the machine learning model. And then 5, not to be, again, looking at everything as this is magic. If you go about it methodically, you'll realize that if you take the steps that are recommended by people who have done this, you follow them, at the end of the day, the results come, and then it no longer looks like magic, and that it's real. It's time for, if you're not already into machine learning and AI, it's something for you to think about getting into, and go take that forward. So the reality, as you have seen, is that we have seen enterprises no longer wondering whether AI and machine learning can produce results. If they are producing results, there's a lot of opportunity remaining. Like I said, the key is making sure that you have the proper guidance, you take the proper steps, and identify the right way to drive the innovation that is going to be then dependent on like leveraging advanced technologies and advanced decision-making ability. So from our experience, we see this as a typical journey for most customers to take from their starting to getting into the technology to how you take it into production. So the first it starts with working with experts together to identify the right business use case to solve with the machine learning capability, then to take that and with that identification of those use case, do an experiment, what is called as a prototype. The idea is to learn from that, get confidence, and more importantly, set a success factor up front that you can meet, so it builds the confidence. It also helps you identify what are the things to look for from a change management perspective that you'll have to consider. Follow that up with the pilot, to do a pilot which is a limited scale pilot in production. As we all know, it's always people, process, and technology. Change is all important regardless of technology. And so you take the learnings from pilot, you use that to then drive the adoption in production. So at Pluto 7, the way we go about helping our customers do this is we always recommend a one-day workshop to help work together to identify the best use case or a set of use cases, or even prioritize the use cases to go after the innovation using machine learning and AI. And then we follow that up based on the use case that's identified to then do that experiment, what we call as proof of concept, take those learnings, the confidence build, and then help the customer put that through a production rollout. So with that, I'm done with the formal presentation. I'm going to now go through a set of questions that came in while I was talking about presenting the information to you. So one of the questions is, why are you using Google Cloud Platform for your machine learning services over other cloud providers? A very good question. Personally, I just want to disclose that Pluto 7, we are a single cloud service provider, meaning we are not providing by choice any solutions on AWS or Microsoft Azure. That is our strategic choice. That is the reason why we are using Google Cloud Platform. And the underlying reason for that is the fact that when we compared for our purposes, the way our journey started was we wanted to come up with a SaaS solution to do exception-based planning for supply chain. And we considered AWS as one of the potential public clouds to use for our solution. When we compared AWS and Google Cloud, we realized that the AI and the machine learning infrastructure and capabilities of Google are far superior than most of the other cloud platforms. And since that was an important factor for us, that was one of the decisions that we made to be not only going with Google Cloud Platform, but then having received the experience and the expertise across our team, we then made the further decision to focus only on Google Cloud as our choice of providing solutions to our customer. So, okay, we have another question from the audience. How much data do I need to implement machine learning on Google Cloud? Another excellent question. Again, I will come up with an answer that I'll say it depends, but I'll give very specific examples to help you. So, for example, if you're talking about, by the way, it's not about necessarily the amount of data as the quality of data, and I'll explain that in a moment. If I'm talking about the amount of information that's needed, for example, for demand forecasting, considering the fact that when you talk about forecasting, seasonality comes in, there are variations that you need to track. For forecasting, you have to have at a minimum 18 months of data, just so that you are able to look at seasonal repeats or look at intermittency of the product use, buying patterns, and so on. In case of demand forecasting, that's the minimum that's required. The more, the better. In certain situations, like for example, if I'm taking a sensor information about, let's say this device is, you want to have an oven that bakes is used for heating the product to bring it to a certain amount of processing. Now, temperature control in this oven is something that's important to be maintained. And let's say you're developing a solution for that. Now, in this situation, you are going to deal with enormous amount of information because this data is captured like over seconds. So in this case, maybe even a month's worth of data, or even I would say a few weeks worth of data is good enough, depending on the kind of process, because it's enough to for the machine to identify the trends. So the point is, depending on the use case and depending on the information, you have to have the right amount of information. It's not like you always need zillions bytes of data. In some cases, you need, depending on the use case, the right amount of information. The other aspect is, I want to also point out that it's not about how much data, but also how good is the data. That is also important. For example, if you have a lot of information from sensors, but the sensors are faulty, that data is need to have good data in addition to having the right amount of data. Okay, there's one more question that has come up that I would like to answer. And the question is, what is the right mix of for a team to achieve the kind of machine learning and AI results that you have seen? Well, I don't think I made this explicit in my slides, but I'll make it now. For any machine learning AI project, whether it's a proof of concept experiment that you have to do, from our experience, these three skill sets have to come together. One is your functional and the business experience. Two, your data engineering experience. And three, the machine learning expertise. In most of our model development, we see that about 70 to 80% of the time is spent on data engineering. And the reason for that is most of the data in the real world is never clean. You need to be able to clean the data, and you also need to do, as a lot of machine learning practitioners will tell you, you also need to do a lot of exploratory data analysis to say, to identify the right algorithm and develop the right model to solve the problem, as an example. Okay, let's see if there are more questions. Okay, there's one other question here. Making changes typically in supply chain is very messy. What's your view on that? Well, I think from this gentleman or person's comments, I know, for example, having worked in supply chain, that changes in supply chain are not easy. That's what I'm assuming you mean by messy, that because by default, supply chain is connections between various enterprise or prices, or even within enterprise, you might be dealing with silos. The point that I want to make here is, yes, there's change management that needs to be done to reduce the impact of the messiness, but the cloud computing and AI and machine learning can sometimes help you make the change simpler. And what I mean by that, and I can give two examples. One is and I'll not identify the customer for obvious reasons. About 4 years ago, when I chatted with somebody in this customer's organization, they were talking to me about how the current system, which was on-premise and used for doing demand planning, was breaking down because the number of rows exceeded a certain threshold. And it was happening, there was no solution. Well, guess what? If your messiness is coming because you're running out of power like that, that is easily solved today with cloud, not even machine learning. The fact that you have cloud where it is serverless and you can have highly scalable architecture. For example, on Google Cloud, if you put your information in BigQuery, 4.3 terabyte of information, which is about 100 billion rows, can be processed, and the query can run in something like less than 40 seconds. So when you have things like this, it reduces the messiness, if that's the type of messiness you're dealing with. And Another example could be, for example, if you are trying to figure out how do I do my downtimes, and if you're on a you're forced to have a predetermined schedule, and that is causing, if you're having worldwide operations, well, you feel like there is no real good time for me to do downtime. That's where, for example, predictive preventative maintenance, where you're now tying your predictive maintenance to when it really needs to be done, and it could be based on the machine's probability of failure rather than a scheduled downtime. That could be another way for you to avoid some of the messes that, if you are referring to that as an example. So yes, while things are complex, based on these examples and others that I've seen, I can say that there is opportunity to reduce the complexity that you're dealing with. The key thing here to remember is, don't look at machine learning and AI as replacing humans. Look at it as augmenting the human decision making and making the human decision making even better, where humans have to be involved more as, okay, there is an exception that needs their attention. They can focus their activities in that direction, and all the other mundane activities happen like clockwork with the help of machines. Let's see if there's any other question from the audience. Okay, I guess that's the last question. And based on the time that I have taken and the time that I'm allotted, I think I'm just about coming to the end of my presentation. So thanks to some of you for leaving me the feedback. I hope this was enjoyable and knowledgeable. You got what you wanted. If you have any questions, feel free to send it in. You can see actually my contact. I forgot to put the email there. It is salil@pluto7.com. Just a reminder to everybody, if you just put @pluto7.com, you can send your questions to me, or you can send them through the regular channels through BrightTALK, and I'll be happy to respond, and either myself or with the help of my team. With that, I hope it was a good session, and thank you all for joining. And depending on where you are, have a good rest of the time for you. Thank you very much.